is that hopefully this work will be not too difficult. Order of real numbers is the name of this topic. Overall, just so you know, chapter 10 is all about inequalities. Greater than, less than, greater than or equal to, less than or equal to, all of that stuff. So the first thing that we're going to talk about is just this greater than, less than idea. Greater than, of course, with the line under it, greater than or equal to, less than or equal to. I think you guys are all familiar with those, so I'm just putting them up there as a reminder. These are our inequality signs when we're talking about that, right? Not equal. So anything not equal is unequal, inequality. So the first thing you're going to do is just translate into symbols. So for example, if you see -3 is greater than -5, first of all, is that a true statement? -3 is greater than -5. Is that true? Yes, it is. So just using the symbols, and of course, the translation right there is simple, but I need you guys to be thinking about whether or not they are actually equal, or greater, or less, picturing the number line if you need to. So that's pretty simple. You're going to classify some statements as true or false. So again, just kind of getting into the idea of how positives and negatives compare to each other. If you need to make a number line to remind yourself, you could do that. Now, we could have a series of inequalities like this. When we do this, normally both signs, if there's more than one inequality sign, they both generally are the same sign. We don't usually flip and have both. So, is this true? I see some thumbs up. It is true. So again, just thinking about the number lines, reading the statement, -4 is less than 1, that's true, and 1 is less than 2, also true, of course. Or for example, again, I'm going to give you mostly negative examples just because those are a little trickier. Now here I've got the or equal to, so don't forget about that sign. -7 is greater than or equal to -6, true or false? Okay, I see some thumbs down. I see at least one thumbs up, but it's false. She was just testing me, I think, to see if I knew the answer. So just don't forget negative numbers, right? Again, picture on the number line, the further it is from 0, the smaller an amount it is. So, okay. Now, other than that, the other thing I want to review, I believe this should be review, is absolute value. You are going to see a few mentions of absolute value. Does somebody remember what absolute value means? What is absolute value? Brian?
The number is -8, the actual value is 8.
Okay, so giving an example of absolute. Now, first of all, remember we would use the straight lines around it, so that means absolute value of -8, and Brian said that the absolute value of that is 8, and that's correct. What does it mean, Jana Grace? Good. The distance from 0 on a number line. So the idea here is that it doesn't actually matter if it goes to the negative direction or the positive direction. The answer to absolute value is always positive. We just give the number. So the absolute value, say, of 3 is still 3. It's not -3. It's not opposites. It's always a positive amount. So you're going to see some true or false statements where they're using absolute value. For example, the absolute value of -3 is greater than 3. True or false? True or false? Absolute value of -3 is greater than 3. True or false? Give me a thumbs up if you think it's true, a thumbs down if it is false. Okay, good. Why is it false? What's wrong with this? Kate? Okay, good, because the absolute value of negative 3, of course, is 3. Whoops, we don't need that anymore. And 3 is not greater than 3. What if I put greater than or equal to? Is that true or false? True. So if it was greater than or equal to, then it's true. 3 is greater than or equal to 3? Oh, well, it's not greater than, but or equal to. It doesn't have to be both, it just has to be one, and it is equal to. So just be careful with the or equal to's, and absolute value, again, we've already worked with that for the most part, so that's just kind of a review. Now, the only other thing that you're going to be doing, that's pretty simple, I think. So you'll warm up with some of that. And then the other thing you're going to see is it will say, solve each inequality. So just like with an equal sign or an equation, to solve it means to find the value of that variable. But what you're going to see in the book is if x, and then this symbol means domain. This goes back to chapter 8 with functions. All you need to know is that this symbol, meaning domain, and then you're going to have the curly brackets. If you can't do curly brackets, that's okay. And then you're going to see a whole series of numbers. I'm not going to list them all. The book has a whole bunch of numbers. It goes -4, -3, -2, -1, 0, 1, 2, 3, 4. All of those values. Solve each inequality if x has a domain, meaning these are the values we're going to plug in for x. Okay, so the domain means all the values that the book is saying, use these, plug them in, and see if it makes a true statement. Now, some of these you're going to be able to tell just by looking which ones might work. For example, if I have, in fact, let me pick a different example here. If I had 4x is less than 8. Now, here's what we need to think about. To solve this, what I want you to do is list all possible solutions. Remember, a solution is something that makes it true. Now, I put ... Your book has many more numbers in there, and you're going to need to use all of those numbers, and what you're going to do to solve this, because here's the idea, an inequality has more than one answer. I'm saying this is less than, well, there's a lot of numbers that could be less than that amount. So using all of the ones that the book gives you, you're going to test out each number in the x position to see if it makes a true statement. So we'll just do a couple of them here. We're not going to do all of them. But I'll start with the couple that are here. 4 times -4, so I'm plugging in this first value, less than 8. 4 times -4, -16, less than 8. Is that true? Okay, good. Hopefully you guys know any negative number is always less than any positive number. Now, here's what you're going to do for your answer. You don't say true or false here. You are going to list all the values from the domain. The first one I used was the -4. If it works, it's part of your answer. So I'd go -4, comma, and I'm going to list all the ones that work, and that would be the answer that I box. So again, we could try a couple more. Let's say we do -3. 4 times -3 is less than 8. Now, I do need to see your work. This doesn't take a long time. It's not heavy-duty math. -12 is less than 8. Okay, that worked. Now again, what we're writing down in our answer is the domain number we plugged in that worked. -3 and so on. So I'm not going to do all of those. I think that's hopefully enough for you to get the idea. You can do mental math on some of them. I'm sure you can. But I still want to see a quick little bit of work where you're showing me that it does work. Okay, it won't take too long to write that down. Okay, the last thing. Now again, I believe, oh wait, let me take this back. I think we're not, no, we are graphing today. Last thing we need to do, graphing an inequality. This is where we use a number line. We're not doing x, y values. And we have done this before, I just need to remind you of a couple ways in which this works. So let's say that I ask you to graph, now again, I think I'm just going to have one example, one or two of these. -3, oops, I'm going to put -3 on there, is less than or equal to x, which is less than 2. If we have greater than or less than, we do an open circle. Greater than or equal to or less than or equal to a closed, or if you want to consider a filled circle. Remember that the open circle means we're not including that number. If we fill in the circle, we say including this number. And really what we're doing with our graph is we are showing which values could be true for x. Now, you can start at either end. I'm going to start on the right end. If I cover up that left side, I see x is less than 2. Okay, there's an infinite amount of numbers that are less than 2. Could x be 2? No, because 2 is not less than 2, right? I saw a thumbs down back there. For this part, less than 2, open circle to say, no, not including the 2. And less than, it starts to go this way. All of these numbers, including in between, including the decimals and the fractions that we're not showing, are all true. Now, -3, I know I'm going to stop at -3. If I just look at this part of it. -3 is less than or equal to x. Could x be -3? -3 is less than or equal to -3? True, or equal to. We include a filled circle to show that the -3 is included as part of the answer. So x is all these numbers. So basically, these are our 2 endpoints of our graph. Whatever numbers are here are the endpoints. Everything in between could be the value of x. It could be the whole numbers, it could be the decimals in between. So our endpoints, we have to decide, is it an open circle or a closed circle, a filled circle? Okay, and then everything in between could be a value of x that would make this true. That's it. That's the last type of problem for today. Hopefully not too hard.